Universiti Sains, Malaysia. This event is presented by Student Achievement Acceleration Unit of Faculty of Science and Technology, UIN, Sunan, Gunung Djati, Bandung. It's been a great honor for me, Rismawati Ramdhani, to be the master of ceremony of this event. And welcome everyone again here on our Zoom meeting room. Before we proceed to the programs today, we would like to express our sincere gratitude to Excellency Vice Dean on behalf of the Dean of Faculty of Science and Technology, Dr. Yuda Satya Perkasa. Honorable the Chairperson of Guest Lecture 2022, Dr. Tety Sudiarti. The keynote speaker, Associate Professor Dr. Muhammad Hazwan Husin from Malaysia, and our distinguished guests and participants. Ladies and gentlemen, our next agenda is the recitation of Holy Quran, which will be recited by Bapak Afaz Fauzi Nurul Najib, Bachelor of Science.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. لو أنزلنا هذا القرآن على جبل لرأيته خاشعا متصدعا من خشية الله وتلك الأمثال نضربها للناس لعلهم يتفكرون هو الله الذي لا إله إلا هو عالم الغيب والشهادة هو الرحمن الرحيم هو الله الذي لا إله إلا هو الملك القدوس السلام المؤمن المهيمن العزيز الجبار المتكبر سبحان الله عما يشركون هو الله الخالق البارئ المصور له الأسماء الحسنى يسبح له ما في السماوات والأرض وهو العزيز الحكيم صدق الله مولانا العظيم. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Pak Afaz. Excellencies, our distinguished guests, ladies and gentlemen, we would like to invite the Vice Dean on behalf of the Dean of Faculty of Science and Technology, Dr. Yuda Satya Perkasa, to deliver his opening speech.
Okay, thank you, Master of Ceremony. Did my sound is hearable?
Yes, it's clean.
Hello?
Halo, Pak. I'm here. You?
Okay. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Alhamdulillahirrahmanirrahim.
wabarakatuh.
Wassalatu wassalamu ala asrofil anbiya'i wal mursalin wa ala alihi washabihi ajmain amma ba'du. The honorable guest lecturer today, Associate Professor of Industrial Chemistry, Dr. Mohd Hazwan Husin, Honorable the Dean and the All Vice Dean of Faculty of Science and Technology, Bandung, Honorable the Chief of Chemistry Department, Faculty of Science and Technology, the Honorable of Chief of the Student Achievement Center, and my dear lecturer and all of the students. Good morning, everyone. It gives me an immense pleasure in welcoming all of you in the second annual guest lecture on the behalf of the Faculty of Science and Technology. And I would like to address a great appreciation to our guest lecturer today, Mr. Mohd Hazwan Husin from Universiti Sains Malaysia. As we all know that the world population is increasing rapidly. Agriculture and energy provider face a difficult task to meet increasing demand of food, feed, fiber, and fuel. Without careful consideration and implementation, disastrous consequences. In the lack of condition, issues related to the sustainable agriculture, production, and energy security are globally becoming more and more important effort. This lecture that will be conducted today by Mr. Mohd Hazwan Husin will bring comprehensive study of how to utilize the side product of the oil palm to provide the demand of energy and the other biomaterial. As cited in the paper that was published by Aliah et al. In Fundamental Processing and Application 2022, he said the Southeast Asia is blessed with the most fertile land. As the consequences, agriculture industry and biomass product become most popular in this region. Aliah also said Malaysia is gearing up to unlock the wealth creation potential of its biomass industry. Area of focus include biomass as energy by converting biomass into solid biofuel, biomass power plant project, and liquid biofuel, such as diesel and ethanol. In Indonesia, according to the study that conducted by A. Hambali and M. Rifai in IOP Conference Series, Earth and Environmental Science, he said that the waste products from palm oil mills spread all over 22 provinces in Indonesia and can be utilized as source of the alternative fuel, fertilizer, chemical compound, and biomaterial. Once again, on behalf of the Faculty of Science and Technology, I would like to express my great appreciation to Mr. Mohd Hazwan Husin for delivering a lecture to our student. The last but not least, let's open this guest lecture by saying Basmalah. Bismillahirrahmanirrahim. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Yuda Satya Prakasa, for the speech. And now we would like to invite Bapak Yusuf Rahmatullah, Master of Science, to deliver doa.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Baik Bapak Ibu, kita sejenak menundukkan kepala kita untuk bermunajat kepada Allah Subhanahu wa taala. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Hamdan syakirin, hamdan na'imin, hamdan yuwafi ni'amahu wa yukafi'u mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhikal karim wa 'azimi sultani. Allahumma shalli ala sayyidina Muhammad. Allahumma shalli ala sayyidina wa habibina wa syafi'ina wa maulana Muhammad wa barik wa salim. Amin. Allahumma ghfir lana wa liwalidayyana warhamhuma kama rabbayana shighara. Allahumma la sahla illa ma ja'altahu sahla wa anta taj'alul hazna idza syi'ta sahla. Allahumma aftah lana abwabal ilmi وأبواب الدنيا وأبواب الرزق وأبواب الصحة وأبواب السلامة وأبواب السعادة والبركة والحكمة في الليل والنهار إنك على كل شيء قدير. ربنا ظلمنا أنفسنا وإن لم تغفر لنا وترحمنا لنكونن من الخاسرين. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. سبحانك ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Pak Yusuf. Ladies and gentlemen, I would like to inform you that in the end of this event, we will share you the attendance form for sending the certificate. Para peserta yang berbahagia, di akhir acara kami akan bagikan link daftar hadir. Mohon untuk diisi dengan tepat. Sertifikat akan dikirimkan secara otomatis pada alamat email yang diisi pada form tersebut. Ladies and gentlemen, before going to the main agenda, we are about to take pictures together. Please open your camera. Para peserta dimohon untuk mengaktifkan kamera untuk sesi foto bersama.
Okay, ready. 3, 2, 1. Next slide. 3, 2, 1. Next. 3, 2, 1. Okay, thank you.
Thank you very much. Ladies and gentlemen, following up is we are going to have the keynote session, which will be moderated by Dr. Tety Sudiarti. Please welcome.
Okay, thank you very much for Dr. Ismawati Ramdhani. Assalamualaikum warahmatullahi wabarakatuh. Good morning all.
Waalaikumsalam. Good morning.
Honorable, I appreciate deeply to our guest, Associate Professor Dr. Muhammad Hazwan Husin. Welcome to Indonesia, Pak Hazwan. Hello.
Yep, thank you.
Assalamualaikum Pak Hazwan.
Waalaikumsalam warahmatullahi wabarakatuh.
Ya, baik.
Yes, I can hear you, but it's a bit lagging. I'm not sure whether it's my connection or it's from the other side.
Okay. Okay. Thank you. Pak Hazwan, attendance, and so far we communicate. Hopefully, we are able to meet you in person in Malaysia or in its time. I mean, Pak.
Yeah, inshallah, we are looking forward to have or to start the mobility with students or lecturers from Bandung. And I think probably today I'm going to share what will be some other opportunities which we can joint venture in the near future. And hopefully the students and also the staff going to benefit from this newly joint collaboration, inshallah. Hello.
Hello, sir.
Yeah. Okay. Yeah.
I'm
I'm
sorry.
just checking. I thought I was talking to myself. Okay.
There are trouble
Yeah.
here. I'm
Okay.
sorry.
Sure. No problem.
Please wait us just a little.
Okay, Assalamualaikum. I'm very sorry, Pak Hazwan and the audience. This is the disturb the connections accidentally. And okay, I appreciate deeply for our guest, Pak Hazwan, Associate Professor Dr. Muhammad Hazwan Hussein from School of Chemical Science, University Sains, Malaysia. Apa kabar, Pak?
Alhamdulillah sehat, baik.
Ya, kami juga di Indonesia, alhamdulillah, Pak. Sebelumnya banyak gempa juga.
Ya, oh ya.
Alhamdulillah sekarang sehat-sehat semua.
Mhm.
And good morning all, and especially for the students. This is the March students, and I hope you are able to pay attention to look up the presentations so that you are able to get much knowledge and you'll improve your insights, hopefully. And before to move the presentations of our guests, I'm going to read curriculum vitae from Associate Professor Dr. Muhammad Hazwan Hussein. Please to share the curriculum vitae CV. Okay. About Associate Professor Dr. Muhammad Hazwan Hussein received his Bachelor of Science in Chemistry and Master of Science degrees for Universiti Sains Malaysia, respectively. He was awarded double PhD degree program with USM and University de Lorraine, France, and also was awarded the best PhD research by Institute of Postgraduate Studies, USM. His research area involved polarization of lignocellulose, biomass for advanced material applicants, and corrosion protection. He was listed as top 2% scientists in the world under the category of 29, 22, and 21 citation by Stanford University. He is also a research fellow at the CGO's Djati, UNIMAP, and a visiting professor at the University de Lorraine, France. He was published more than 150 papers of his research work in reputable journals and also presented many scientific papers in various conferences nationally and internationally. He's an associate editor for Frontiers in Chemistry, Green and Sustainable Chemistry, and review editor for Frontiers in Material Environmental Degradation of Materials. Presently, he is associate professor at the School of Chemical Science, USM, and the Deputy Director of Research Management and Credibility Office, USM. Okay, well, this is the outstanding performance, Pak Hazwan. Okay, before move the primary sections, I'm going to inform you, Pak Hazwan, you have about 50 minutes to present, and after that we are going to conduct discussions about 10 minutes. Okay, and for all, you are able to propose your questions by chat or by raise hand. Okay, it's your time to present, Pak Hazwan, so please.
Okay, thank you very much, Dr. Tety. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. And very
Assalamualaikum warahmatullahi wabarakatuh.
morning to everyone. Basically, I would like to take this opportunity to thank the organizing committee for arranging this sharing session today. And I would like to convey my gratitude as well to the Vice Dean in Academic Field, Dr. Yuda Satya Prakasa, Dean for Faculty of Science and Technology, and also lecturers in the Faculty of Science and Technology, Universiti Islam Negeri Sunan Gunung Djati, Bandung. Alhamdulillah, what we are, a main objective for our sharing session today is basically to share a little bit what we have done in these few recent years. And obviously, later on, we are going to look at some other opportunity that we have in University Science Malaysia, especially in terms of student and staff research mobility. Again, as what have been introduced by the chairperson, I'm currently the associate professor in the section of industrial chemistry, School of Chemical Sciences, University Science Malaysia. And my field of expertise is basically on utilization of lignocellulosic biomass and the application more specifically for corrosion protection, coatings, adhesive, composite, and whatnot. So before I think I share my work, it is best to know our university as well as where we are looking at. Where we are located at. University of Science Malaysia is actually located in Penang Island. I'm not very sure any of you have been to Penang Island. It is actually located slightly in the north of Malaysia Peninsula, and basically we are blessed to have our university in this island because of its diverse cultural and also ethnicity provided in this island. And if you can see in this small island, we have lots of attractive places, especially the capital city. Georgetown is one of the UNESCO World Heritage Site, and you can see a lot of attractive places provided in Penang. And also we have this one, a tram that commute between the Penang Hill. If you happen to be in Penang, it is a must place to go. Penang Hill. And furthermore, we are surrounded by beaches. We have a lot of beaches. For example, like Batu Ferringhi beaches. And we also have a botanical garden. It's considered one of the oldest botanical garden, I think, along botanical garden in Bogor. I've been to Kebun Kota in Bogor, and it is actually almost similar environment. So it's actually very rich with different types of species of trees, plants, and whatsoever. And the most iconic, symbols of Penang Island is basically Penang Bridge. So we have two different Penang Bridge, the first bridge and also the second bridge. Both are actually considered one of the longest bridge in Southeast Asia. And our university is actually located very near to first bridge. If you cross the first bridge, which actually connects Penang Island and also the mainland of Malaysia, at the end of this bridge, this is where our campus is located at. And it's not really far. Me, myself, I'm actually commuting from the mainland to the Penang Island every day. It took like around half an hour drive. And basically, you can see that this only the location or the area that it is actually green. The rest is actually just tall buildings, apartments, offices, and whatsoever. So you can see this just our campus that is more or less surrounded by the trees. We have ponds, lakes, and whatsoever. So University of Science Malaysia, our main vision is actually to aspire or we want to be pioneer in transdisciplinary research, and we would like to provide some, knowledge to our future talents and enables the bottom billions. What we are talking about, the bottom billions is our people who are actually having a slightly moderate income or low income, so that they can actually receive the training or the knowledge which able to shift their social life from maybe a medium class or lower class into a slightly better class. And our university, at the glance, we are the second oldest university in Malaysia after Universiti Malaya. We have been established since 1969. I think in comparison to Universiti Malaya, I think Universiti Malaya was established even a long time ago. And for your information, Universiti Malaya also share the same history as National University of Singapore, because both university was previously the same university before they separated. And I think during colonial time, most of the higher education at that time was based in England. It means that if you are doing well in your high school and you want to further for tertiary education, most probably you will have it in England or United Kingdom. But after independence, there was a need to have our own university. And I think after Universiti Malaya, because it's actually we are having more and more students, so that is why the establishment of University of Science Malaysia. Before University of Science Malaysia was named, it was I think previously called as University of Penang, not as University of Science Malaysia. I think in the year 70s, early 70s, we changed into University of Science Malaysia, and it is the first and only university that had been awarded with APEX status. APEX means Accelerated Program for Excellence by Malaysian government since 2008. So this program is basically to as a role model for other university in order to excel in terms of research, teaching, and other activities. And USM is also one of the research university in Malaysia. So we are, along with Universiti Malaya, Universiti Kebangsaan Malaysia, Universiti Putra, and also University Technology Malaysia, which entitles with research university. And as a research university, we receive a yearly funding from Malaysian government to undergo research intensive activity so that we can actually be as one of the university in the world ranking. So the mission and vision of our university is basically we are focused on transforming higher education for sustainable tomorrow, and we actually embrace the values in terms of quality, equity, availability, accessibility, affordability, and appropriateness. And along that way, we also been headed by different people. This is actually our previous Vice Chancellor, because we just had our election. So at the moment, we don't have a new Vice Chancellor. We only have a caretaker at the moment. But the Deputy Vice Chancellor is still doing their job. The previous Vice Chancellor is Professor Dr. Faisal Rafiq Muhammad Adikan. And the Deputy Vice Chancellor, who is also the caretaker for the university at the moment, is Professor Datuk Geospecialist Dr. Narima Sa'ad. She is actually the Deputy Vice Chancellor for Academic and International. We also have Deputy Vice Chancellor of Research and Innovation, Professor Datuk Insinyur Dr. Abdul Rahman Muhammad. And I actually work very close with Professor Rahman because presently I'm also the Deputy Director for Research Office. So I'm also doing, some other tasks in terms of like giving grants, also, being active in any research activity for university. And apart from that, we also have Professor Dr. Azlinda Azman. She is actually the Deputy Vice Chancellor of Student Development Affairs and Alumni. And finally, we also have Professor Dr. Muhammad Roslan Hashim. He is the Deputy Vice Chancellor of Sustainable and Institutional Development. So our university is also called as a green university because we are surrounded with different types of trees. And for your information, for our campus, in order to cut or to prune the branches, it needs the permission from the Vice Chancellor. So we really want to embrace eco and sustainable environment to our students. So that is why I think we don't cut trees. In the campus, normally we let the trees grow so that the student will have more oxygen and will have more shades for walking or jogging. And our university actually have different campuses. It is not mainly located in Penang Island, but we also have different campuses which cater different programs. The main campus, as I said, located in the Penang Island, this called as a Minden campus. And then we also have engineering campus, which located in Nimbun Tebal. This is where all engineering courses been placed. And then we also have IPPT. This actually stands for Advanced Dental and Medical Institute in Bertam. So I actually stay very near to Bertam area. So I commute like almost every day to the main island. And then we also have other campus like Sains at USM, where it hosts mostly Center of Excellence, research centers and research institutes as well. And we do also have Institute of Postgraduate Studies at Kuala Lumpur, where I think most probably the business program have been programmed over there. And finally, we also have health campus in the other states in Kelantan, in the East Coast, where all the health programs like medical, dentistry, health sciences, forensic, and whatsoever have been program over there. And we do have our own hospital, HUSM, we call it, in Kelantan. And for your information, we also have an overseas campus in India. It is called as USM KLE, International Medical Campus in Belgaum. So this campus is actually cater medical student. So students who actually undergo their maybe 3 years or 4 years of training in Kelantan, they will be sent to India to undergo clinical studies and I think some other advanced studies in India. Well, we are more than 50 years, and I think for your information, we have around 30,000 plus students, be it for undergraduate, postgraduates, around 10,000 plus staff for academics, professional, and support, and over 50 plus of schools and also PTJs. So for school, because in USM we didn't use faculty system, we use mostly school system. So we have our own dean for each schools, meaning that for chemistry we have our own dean, for physics we have our own dean, and I think it's not like a faculty system where you combine all the departments and you have only one dean for one faculty. And we also have the higher institution centers of excellence, high COE 3, and 14 center of excellence, and the other strategy and services center, and I think around 8 students hostel. So this is basically the breakup of the schools and also the other departments. I'm not going to go one by one. And yeah, for the international student, for your information, we have around 4,000 plus students from different countries. Around almost 2,000 actually for doctorate programs, 700 plus for master's program, and 400 plus for degree program. This is actually the breakup for international, but in total, if you count together with the local students, we have around 34,000 plus of postgraduate students, and the other breakup is for doctorates, masters, degrees, and whatsoever. So our main strength in terms of research, we are more focused on advanced material, which will be in nanomaterials, engineering, environmental and water research, and finally precision medicine. So all this niche area is actually being categorized basically based on the QS ranking. So we have more papers published in this area rather than the other areas. And of course, our research direction follows Malaysia's socio-economic drivers. And we actually support the national agenda, especially in the science and technology opportunities. So some slight introduction about our department, the School of Chemical Sciences. Our program is basically accredited with Royal Society of Chemistry, UK, and also Malaysian Institute of Chemistry. So our department is considered as one of the oldest department, or probably as the founding department in USM, along biology and also mathematics. So if you look at the building, is also an old building, I think since early 1970s. And then for the academic staff, we have around 30 plus of academic staff from different sections: analytical chemistry, industrial chemistry, physical chemistry, organic chemistry, and also inorganic chemistry. And our researchers also have received several awards, like for example, top 2% in terms of highly cited researchers in the world. And I think probably like this year, 6 are from School of Chemical Sciences. And in terms of administration, we have around 16, and lab techs around almost 30 person. And our school actually engage a lot with industry and also community, where the academic lesson is not only focused on giving lectures, but also in terms of like engaging with industries. We place our student in industry for several months for training, and then after that they can come back and actually they will have more exposure in terms of like what will be the life as a chemist or process engineers and whatsoever. And for our program, for undergraduates, we have 3 different programs: Bachelor of Science in Pure Chemistry, and also the other 2, Bachelor of Applied Science in Analytical Chemistry, or Bachelor of Applied Science in Industrial Chemistry. So for postgraduate programs, we have research mode and also mixed mode or coursework modes, where for mixed mode program, we have a Master's in Chemical Instrumentation. This is a 1-year program. Meanwhile, for research program, will be around 3 years to 5 years program. So the specific areas will be varies depending on the interest of the students. But what make our program in chemistry is slightly interesting is that we have a dual master and PhD program joined together with University de Lorraine, France, as well as the other university, like for example, Nagaoka University of Technology, and I think the latest one we have NTU, National Taiwan University, where we offer a double PhD and double master program. So for Masters of Science in Chemical Instrumentation, this obviously for those who are interested to further your master's program in USM. We have this mixed mode program, and some of the courses offered will be as follows. And as myself, I'm also teaching one of these subjects, especially on electrochemical methods. And our facilities normally is at par with the other universities. We have the basic facilities like chromatography units. We also have the NMR units. We also have the elemental characterization like ICP-OES, AAS, thermal analyzer, TGA, DSC, AAS, mercury analyzer. And our department is also special because we have this glass blowing workshop. So since we have our own glass blowing workshop, it means that our apparatus and also our experiment can be fabricated in this workshop, so that anything that requires a special experiment, you can actually do it in this workshop, and it will be assisted by lab techs. So just to show you, we just had our convocation last week until yesterday. We just finished our session yesterday. So this is basically our Chancellor. The Chancellor is actually sitting in front. He is actually the King of Perlis. Perlis is one of the state nearby Penang. And beside him is our Pro-Chancellor. The Pro-Chancellor is actually a renowned or honorable person in Malaysia. And besides will be the Emeritus Professor, and behind will be the top management, Vice Chancellor, Deputy Vice Chancellor. And at the back with red robes, you will see that they are actually the deans or director for institutes and whatsoever. So just to show you some scenario or some pictures taken during the convocation in our department. And we also have Universiti Sains Malaysia, Universiti Deloin Center located in the campus. So currently, I'm also the coordinator of this program. So this program actually offers mobility between USM and also France. So if you are interested, you can also communicate with me. And some activities which includes mobility, we do receive students from France every year to undergo attachment or stage. And then our students also been sent to France for a PhD attachment or master attachment. So I would like to share with you some inbound and outbound programs that offered by Universiti Sains Malaysia. We do have a center called IMCC, International Mobility and Collaboration Center. So for every year, there will be some opening in case of you want to do an attachment in USM, and you can check to IMCC website, and normally there will be a deadline. But this deadline is normally for student exchange program rather than research exchange. So for research exchange, there will be no deadlines, so you can submit your application at any time. And then the application process, of course, if your attachment requires a visa, then there will be some process that requires. So you need to communicate with the, coordinator, Djati, and then she will actually process your application for visa approval and whatsoever. But if your attachment actually wouldn't require you with a visa, let's say for Indonesia passport, I guess you are entitled to stay in Malaysia for not more than 30 days. So in this case, if the activity is less than 30 days, so you wouldn't need any visa for your attachment. So of course, this one, if your stay is actually beyond 30 days, then you need to apply EVA, e-visa approval letter by EMGS, Education Malaysia Global Service. And then this will be assisted by our IMCC officer. And I guess for any interest in terms of undergoing a student attachment and whatsoever, so you can or you are pleased to talk with me. Basically, what I want to offer to students in Universiti Islam Negeri Bandung is basically on student attachment. So we can actually provide you some intensive research attachment, less than 30 days, probably like around 2 weeks or 3 weeks of stay. And your accommodation will be sponsored. Okay, and obviously your accommodation will be in the student's hostel, and I think there will be some allowance, meal allowance will be provided. But I think for this research attachment, the flight ticket is not provided. But I assume some universities also provide this mobility assistance program where it can actually help the student to support the flight tickets and whatsoever. So this is what we always do with France, with Japan, with Taiwan, where they actually obtain the mobility assistance from their university to support their flight tickets. But we will actually take care of their stay in Malaysia. And if they are working on a specific projects, we can pay some allowance to them during the stay. I hope probably if you have any other question, I'll be open after my presentation. So the next part will be on sharing about my research work, especially on biomass and its application. So then the title for today's presentation is mostly on oil palm fronds, lignocellulosic materials, a comprehensive studies. I've been working a lot with oil palm residues or oil palm waste since my PhD time until now. So I assume that in Indonesia, the activities on utilizing oil palm biomass waste is also active currently. So probably some of you will find some interest from my presentation, and we can actually talk for future collaboration and etc. For your information, what does it mean by lignocellulosic biomass? The name itself, it means that the types of materials are actually coming from biological materials or living or recently living organisms. So we are talking about plants, we are talking about animals, or we are talking about other types of materials that can actually contribute to this lignocellulosic biomass. And the production of biomass elsewhere in the year, in the world, every year is actually around half of ocean and half of the land. So it means that from palm oil activities, from rubber activities, from corn, or from other types of agricultural activities, it actually produces massive amounts of biomass. And this number is actually quite worrying because you can see it can cause environmental threat if this biomass is not being utilized further. But currently, scientists found that this biomass can be used as a promising source of renewable energy. And the main component of lignocellulosic biomass is mostly cellulose, around 30 to 50%, hemicellulose 20 to 30, and lignin around 15 to maybe 30%. And the current trend is actually not only to use it as a renewable energy, but people actually use it to produce more refined chemicals by employing different types of thermochemical methods. So the main concept in biorefinery is when you have a biomass, you need to do some preliminary binary process, which in this case, it will be a pre-treatment or fractionation. So this actually will separate the main component of lignocellulosic, which is hemicellulose, cellulose, and lignin. And further, it will be subjected into other biorefinery process, which actually can refine all these chemicals into different types of material, which will be useful for its future application. The biomass in Malaysia, basically we focus a lot on palm oil, but other than that, there will be on wood, rice, sugarcane, and other types of waste. I assume that the trend between biomass production in Malaysia and Indonesia is more or less the same. And our national biomass strategy 2020 has actually plan that we want to use this biomass for the production of bioplastic and biodegradable polymers for food packaging and whatsoever. And talking about more specifically on oil palm biomass, Malaysia has been like second after Indonesia in terms of like producing the biomass waste. And for our own statistic, it's around 50 million tons of biomass being produced without further utilization. And this biomass can be clustered into different parts, especially on empty fruit bunches, which around 4 million tons per year, oil palm fronds around 34 million tons per year, and oil palm trunk around 3 million tons per year. And for your information, my thoughts today will focus mostly on oil palm fronds because this part of biomass is actually huge in number. So you can imagine that the fronds, people are actually prune it and leave it on the ground. Because if you prune the fronds, you can actually let the tree grow straight and producing more bunches. But since the fronds have been pruned and left on the ground, that actually creates environmental threat and some other problems in terms of the disposal and whatsoever. So in order to separate lignin and cellulose, we need to undergo a so-called delignification process. We can imagine that the wood structure itself comprises of the main component as mentioned before. But the purpose of undergoing delignification or pulping process is to separate the main components so that you will have a more pure lignin, more pure hemicellulose and cellulose. Pulping process is mostly used in paper industries, but the black liquor or the resulted liquid after this process has been discarded as well. And this black liquor is actually very rich with lignin. And the lignification process can be done using a high pressure, high temperature reactors with the addition of specific chemical and known solid to liquid ratios. So there's a different process, for example, craft process, where you are going to use chemicals like, for example, sodium hydroxide and sodium sulfide with a temperature around 150 to 180 and the time around 1 to 3 hours. So the process is actually quite severe. So why we want to maintain a severe process is that we want to ensure that the lignin that's going to be isolated will be slightly high in yield. And I think we want to extract as much as lignin as we can. And for crop process, what actually interests us is that the functionality of the lignin in the end is that it will actually have these sulfide functionalities because of the sodium sulfide chemicals being used. Other than that, it will be on soda process. More or less the same. Both processes are actually alkaline process, but we didn't use sodium sulfide in this process. We only use soda, which means sodium hydroxide. Temperatures and time is almost the same. And the functionalities of the lignins extracted, it doesn't have any sulfide functionalities. And finally, we also concentrate on organosoft process, where in this case, we are using organic solvent rather than inorganic salts or alkaline salts as the active ingredient. So the chemicals that have been used normally is ethanol, but you can also have acetic acid or ethylene glycol as the solvent with a different ratio with water and some amount of mineral acid as a catalyst. Temperature is slightly higher, 150 to 190 or almost 200, but the time will be slightly shorter because when you use organic solvent, the amounts of vapor produced inside the reactor will be huge, and the pressure produced is also going to be slightly high as compared to alkaline process. The comparison between the two processes, obviously alkaline process and also organosoft process. Alkaline process will produce slightly higher yields of lignin, and organosoft process will produce slightly lower yield of lignin. But in terms of the purity, in terms of the characteristics of lignin produced from organosoft is even better. It actually provides better antioxidant activity as compared to kraft, and even solubility for organosoft lignin is better than kraft lignin, because in kraft or alkaline process, you will obtain a slightly condensed structure, a bigger structure of lignin, which have some difficulty in terms of solubility and etc. Probably you've heard about lignin as what I've mentioned to you just now, but you are not sure what is actually lignin. So lignin is basically a polyphenolic compound that composed of major monomers of paracommune alcohol, was alcohol, and also stringent alcohol. It considered as a waste product from pulping or bleaching process. As I mentioned, during the pulping process, if you want to produce paper, they will treat the wood and use chemicals. They will take the pulp, which later on used to produce paper, but the black liquor they just discard it. And this black liquor is very much rich with lignin. And lignin is also considered as a non-toxic complex structure and natural phenolic polymer. And it has been increasingly important for many applications, such as for binder, dispersant, and also emulsifier. But obviously, lignin have a limitation because the structure is actually hyperbranch and complex in structure. It has a very huge molecular weight, and it is actually hydrophobic in nature, so it's less soluble in water, especially in neutral condition, but it can actually dissolve in slightly alkaline solution. And due to its stability, it has a very low chemical activity. So we have a chance in terms of okay, right. We have a very low chemical reactivity. It means that the structure of the lignin itself, if you want to do some grafting or if you want to do some modification, it will be difficult because the structure itself is quite stable and it doesn't have much active site for interaction. So all these are actually our limitation, which we have to tackle during our research. So our research, actually we want to have a lignin that have a better in terms of solubility and also functionality. So that is why we need to do some modification in order to make our lignin more functionalized and can be useful for our application. So some other modification that we have done is by using different types of pulping techniques. Other than that, we also introduce organic scavenger. So this technique actually I learned during my PhD time in France, where we incorporate scavengers or chemicals during the pulping process. And when it actually forms the intermediate of carbonium ion, it will actually interact or graft with the organic scavenger and forming a smaller fragments of lignin. So smaller fragments of lignin can actually ensure us with a higher yields of lignin, rather than if it didn't have any scavenger, it will actually combine by itself and forms a more condensed structure. And finally, we also concentrate on the modification by means of fractionation of lignin by using selective precipitation, ultrafiltration methods, and etc. So the first modification we did was using combinative treatment using the scavenger. So what we did was we soaked the biomass with the chemicals, which in this case 4% of 2-naphthol or dihydroxyanthoquinone. So we perform autohydrolysis so that most of the hemicellulose will be extracted out, and hemicellulose can actually jeopardize the lignin extractability. And after we recover the pulp, we subjected it again into the reactor and we do the pulping process in order to isolate lignin. And once we get the black liquor, we precipitate it and we can get the lignin powder. So of course, when we do a modification, it is always important to check whether the lignin structure have some other difference or actually experience modification. So we did some basic analysis like using FTIR. So we can actually see that with the addition of organic scavenger, for example, with naphthol, we noticed that there is actually an addition functionalities, especially at around 800 with numbers, which actually suggests that there's actually a presence of naphthalene moiety into the lignin structure, as well as the dihydrocyanic anthraquinone. And we also use phosphorus NMR in order to quantify the aromatic content. And what we have actually observed was that when we actually modify the structure of lignin via combinative retreatment, there will be more aromatic rings or aromaticity present in the lignin structure. And due to this reason, it actually gives us a more properties in terms of like later on for antioxidant or solubility. And we also noticed that after we have like introduced the organic scavenger, the Hebert ketone, especially at 1700, is slightly reduced. So it means that there's some interaction that happens because the carbonyl functionalities is actually very much active to play a role in interacting with the organic scavengers. We also did advanced technique like two-dimensional NMR, like in this case HSQC, single quantum NMR. We just want to see the clustering of organic scavengers rather than the presence of lignin. So without modification, you wouldn't see any presence of naphthalene ring or dihydroxyanthraquinone. You just see the presence of the main monomers of lignin. But after the modification, you can see the presence of naphthalene ring and also dihydroxyanthraquinone. And we also perform HMBC, multiple bond 2D NMR in order to explain where does this interaction located at. So this experiment actually will give us some guide that the modification of lignin can happen, especially at the carbon 2 or carbon 3 of naphthalene ring. Meanwhile, for dihydroxyanthraquinone, we noticed that from HMBC NMR, it can be proposed that the interaction with lignin could be either at carbon 3 and also carbon 6. And after that, we also look at the antioxidant activity. So we did oxygen uptake inhibition studies. This was done in France, where this antioxidant assay is slightly interesting because we measure the partial pressure of oxygen produced after we add radicals. So if the antioxidant is actually good, it wouldn't produce much partial pressure of oxygen. And obviously, when we modify the lignin, it provides us with a slightly higher oxygen uptake inhibition rather than without modification. And then with ferric reducing power assays, it also noted that after the modification of lignin, it provides us with a better in terms of antioxidant activity. So the correlation that we did was that if we actually modify the structure of lignin, we obtain a slightly more aromaticity. So more aromaticity actually can help in terms of improving the antioxidant activity by providing more resonance stability, and this actually will give increase in antioxidant activity. And other than that, we also did molecular quantification, like using GPC to check on the molecular weight, and also DSC to check on the glass transition values. So obviously the modification of lignin provide us with a lower size, a lower molecular weight of lignin, which actually can contribute also in terms of the antioxidant activity. And finally, we did the dissolution test. We just want to check whether the modified lignin improve in terms of the solubility in water or whatsoever. So of course, after we have modified the lignin, it actually have an increase more than 20% of solubility rather than without any modification. So this is actually very good for our application, which means that the lignin that we have modified can be used in any application, especially that requires solubility in water. And other techniques that we use is basically on fractionation using ultrafiltration techniques. But first, we need to obtain the black liquor from a pulping process. So this is almost similar to what I have explained earlier on. So after we have obtained the black liquor, we subject it into the ultrafiltration membrane. So the membrane actually functions as, I think, like a filter. It separates molecules with a specific molecular size, which in this case, we are using membrane at around 5,000 kilodalton, or 5,000 Dalton, or 1,000 Dalton PAS membrane. So this actually show you before the experiment, you have a black liquor, and after the ultrafiltration, you will see that the color of the black liquor is slightly pale, which indicates that you have a lower size of lignin that pass through the membrane. And after we obtain the permeated black liquor, we precipitate it, we obtain the lignin, and we characterize it again, of course, using phosphor and NMR. We check on the antioxidant activity and also the dissolution. So from here, you can see that the fractionated lignin produce better properties in terms of antioxidant as well as the solubility. And to proceed further, the modified lignin that we have obtained, we actually try to look at the application as a corrosion inhibitor. Okay. So lignin as a corrosion inhibitor have been studied by a few authors before, but I think most of them actually do some other modification in terms of like electropolymerization, grafting, and whatsoever. But so far, there's no studies that have been done using organic scavengers inclusion or ultrafiltration modification. So for those who doesn't have any idea what does it mean by corrosion inhibitor, it means that chemicals that is added into the environment or into the electrolyte, which can reduce the corrosivity and in the end retard the corrosion process of a metal. So this actually useful for metal protection or different kinds of industries. So what we did was, after we have obtained the modified lignin, we prepare it in a different concentration. We study the corrosion inhibition studies via electrochemical methods. So we perform electrochemical impedance spectroscopy. And what we have obtained was that as we increase the concentration of the lignin, modified lignin inhibitor, it actually provides us with a higher resistant charge transfer graph, values. So this actually indicates that as you actually add in the modified lignin into the solution, it actually can retard even more corrosion of a mild steel in this case. And the inhibition efficiency was attained at more than 90% of inhibition. And this is also supported with another technique, which is called as potential dynamic polarization. So before this, for impedance, we are measuring the resistant charge transfer, where in the polarization methods, we are measuring the current density values. And obviously, as we increase the concentration of modified lignin, the current density will be reduced as well. And this actually will give us a better inhibition, which will be almost 90%. This actually in accordance with EIS experiment that we did earlier. So in order to justify the types of mechanism that happens during the inhibition process, we perform adsorption studies. So in the adsorption studies, we actually feed it with we actually have fitted with different isotope models, especially like Langmuir, Fruitledge, Frumkin, Temkin, and it actually fitted best with Langmuir. And if you actually calculate the Gibbs free energy, it will give us some idea that the types of adsorption is basically more on a physical adsorption. It's actually a types of electrostatic interaction between the charged molecules with the charged metal surface. And this is actually the proposed mechanism that we have proposed in our publication. And this is also supported with the modeling studies that we did. So some other advanced technique that we did was a surface analysis, which without the presence of the modified lignin inhibitor, you can see that the surface of the metal is very much corroded after being exposed in acidic medium. And the XRD spectrum also the spectrogram also shows that the presence of different rust phase, oxyhydroxides and metal oxides. But as we actually introduce a modified lignin, you will see that the surface of the metal is actually very much smooth. And from the XRD, we wouldn't actually show much presence of other types of rust phase. Even from the EDX, you can see that the oxygen content is very much reduced as compared to without the presence of modified lignin inhibitor. So in comparison between the lignin samples, we understand that the correlation between modified lignin properties with anti-corrosion properties, that if you have modified the structure of lignin, it actually improves in terms of the antioxidant activity. So when you have a good antioxidant, it means that it will be a good candidate as well for corrosion inhibitor, because corrosion process is basically oxidation process. And if you actually add antioxidant, this will actually retard or reduce the oxidation process. So further, what we did was we actually extend the project a bit. We produce a product from the samples that we have produced. We actually produce something like a coolant. So coolant actually been used in any industry for cooling process. It actually includes water circulation and whatsoever. But of course, the material used is metal and also, exposed to corrosion, problems. So what we did was we incorporate modified lignin into the formulation, and we did some comparison with other commercial coolant. And from this dipping testing, what you have seen is that after 3 months of dipping with the other types of coolant, the metal surface is very much corroded. But with our samples, there's no corrosion at all that occurs. Just slight, stain or slight localized corrosion that you will see. In fact, from the electrochemical studies and also the surface studies also mentioned that the formulated coolant that we have produced is actually even better than the commercial brand. So what happened is that after that, I become a businessman slightly. We have been approached by a company that deals with metal industries, and they have a problem with pitting corrosion from their products, and they are actually asked me what to do with it. So I actually have proposed to them to use a coolant in order to reduce the corrosion, and they asked me whether I have my own coolant. So at that time, we are producing our own, doing some R&D, and I gave them for free. And they did their own R&D, they compare with the other brands, and they actually have, observed that our coolant is actually better than others. So what happened in the end is that they actually issue us with some purchasing. They want to buy our coolant. So that is what happened. We produced the first batch of 320 kilos of this coolant products to cater their factories. And after that, we also did some field test trial with them. So since they are actually putting at their cooling towers, and we also need the data from the field test trial because of we want to file for patent, and that is why we need to monitor it regularly. So we with the engineers, and we discuss a lot and to see if there's any problems during the process and whatsoever. So the data is actually being shared by the company. So what happened is that after the inclusion of our product, which we call it as lignoX coolant, the rejection rate or the defect have been reduced to less than 1%. So you can see that the rejection rate is actually around 0.3. And they even asked me whether is it possible to make it 0%. I said for corrosion process, it's going to happen anyway, but we still can reduce it. But obviously, before this, they have around 10% of rejection of product every time they do the production. But when they use our coolant, it has been like reduced tremendously. So other types of application that I did was as an adhesive. So adhesive that obviously available in the market is basically formaldehyde-based adhesive, and certain exposure with formaldehyde can cause problem, and formaldehyde is known to be carcinogen. It can cause cancer and whatsoever. So the main idea of utilizing lignin from oil palm biomass is that we want to replace phenol. Okay? We replace phenol with lignin at the same time, and we also replace formaldehyde with a less toxic aldehyde, which in this case we use glycosol. And the basis of resinification process is that when you have a lignin structure, as I mentioned, lignin is actually a polyphenolic compound. So it can be a good candidate for cross-linking process or resinification process to form a resin. So in this case, we can actually react with formaldehyde or with different types of aldehyde to form a cross-linking, and in the end, it will form a resin. There have been a lot of studies that use lignin-based adhesive, but different researchers will use different types of biomass. And so far, there's not much studies been done from oil palm biomass waste. So we actually one of the pioneer of the research on lignin-based adhesive. So again, in order to get the polyphenols, we have to extract the lignin from the biomass. So after the lignin extraction, we actually do the resinification process. We include different percentage of lignin substitution, and then we also include glycosol as the less toxic aldehyde with a fixed molar ratio. And over here, the study also we did with different types of lignin. So we have a kraft lignin and organosoft lignin. So we want to study which type of lignin actually performs better. And after we have done the resinification, we actually concentrate it to make sure that the viscosity of the resin is slightly better. And we actually apply it on the plywood. So after the application to the plywood, we hot press it, we cure it, and it will forms like a panel. So this panel will be cut into small pieces with a fixed dimension to follow STM or Japanese standard before we proceed with the tensile measurement. So what we have obtained is that we characterize the properties of the adhesive. So as we increase the content of the lignin, especially for organosoft lignin, the solid content and viscosity is actually better. So viscosity, the higher viscosity, the better the gel time is. So what does it mean by gel time? The curing rate of the adhesive. So if you have a less curing time, it means that the time required to make the adhesive to harden is in a short time. So we characterize the adhesive that we have produced. So obviously from the FTIR, we have observed that the formation of the cross-linking bridges, so meaning that the resinification process is actually successful. We also did NMR analysis to double confirm the formation of cross-linking. And we also have performed DSC analysis to actually calculate the difference of temperature. So if you obtain a lower delta T value, it actually indicates a higher rate of curing of the resin. So this is actually true and supports our previous characterization in terms of the gel time and also the viscosity. And finally, we also did the mechanical properties of the panels. As I mentioned, we did in a different percentage of lignin substitution. And in this case, the panel is actually in a dry condition. So we obtain a very high tensile for 50% of lignin substitution as compared to kraft lignin. Meanwhile, we also did a wet condition where the panel is actually soaked at the boiling water This is actually to see whether the adhesive or the panel will delaminate or not. So at the lower percentage of lignin substitution, the panel is actually delaminated, but at the higher lignin substitution, for example, 50% of organosorbed lignin adhesive, it actually still give the higher tensile as compared to control sample. And some comparison with the commercial phenol formaldehyde adhesive is that the one that we produce is giving us a slightly higher tensile properties as compared to the commercially available adhesive. And the next part will be focused on cellulose. I guess the earlier part would actually relates mostly on lignin application, but now we are concentrates on the pulp, which is actually rich with cellulose. So cellulose as a nanocrystal and nanofiller for different types of application, we have actually isolated the nanocellulose from the pulp and produce it in a nanostructure. So why nanostructure? Because of it will actually give a higher surface area, and this also will give a good mechanical strength if you actually blend it with a polymer to produce composite and whatsoever. So of course, in order to isolate the cellulose, we need to do pulping process, and after the pulping process, we need to bleach the pulp, and it will actually forms the alpha cellulose, and we actually subject it to acid hydrolysis to perform or to form cellulose nanocrystal samples. So the cellulose nanocrystal sample will be subjected to different characterization. You can see from the FTIR, mostly cellulose, and we also did solid state NMR in order to check the crystallinity of the cellulose that produced. And you can see that the C4 and C6 of cellulose structure, especially for crystal peaks, is even greater than amorphous peak. We also quantify the crystallinity index of the cellulose nano and the the melting temperature of nanocellulose that we have produced. And I think the characterization is not complete if we didn't perform the transmission electron microscope. So this is actually very much important in order to justify that the samples that we obtain is basically nano in size. And further, we also did BET, a surface area analysis. And of course, after the acid hydrolysis, we obtained slightly higher BET surface area than before the acid hydrolysis. The application of cellulose for filler in coatings has been done by several authors. But what we want to do is that the cellulose nano that we have obtained, we will actually blend it together with the epoxy coatings, and after that, it will actually be coated into the metal surface. So this is actually what happened. So after we have actually isolate the CNC from OPF, we actually blend it together with epoxy plus with zinc, and we coat it on the metal surface, and we further test it for anti-corrosion testing as well as surface analysis. For electrochemical studies, what happened is that we obtain slightly better properties of in terms of corrosion resistance, and even the surface roughness of the coated sample is actually even better. I mean, in terms of the smoothness in comparison with or without the coating or coated samples. Some other testing includes adhesion and also hardness test. We did the salt spray test for aging, and obviously from here we see that 0.5% of CNC introduced in the epoxy coating is actually better in terms of aging test. And even for the hardness test, 0.5% of CNC blend with epoxy coating produce a slightly higher hardness. And finally, the application that we did with cellulose nano is that we use it as an adsorbent for wastewater treatment. So there's a lot of cellulose types adsorbent being studied by many authors, but I guess for cellulose nano in wastewater, not much, especially coming from oil palm waste. So similar experiment that we did was we isolate the cellulose nano, and what makes the thing slightly interesting is that we form a base from this cellulose nano. Why we form a base is because for the adsorption studies, we want to make sure that after the adsorption process, we can easily isolate the adsorbent rather than in powder, for example. And to make it more interesting, we also include to the base. So it will be a composite adsorbent. You will have cellulose nano and also activated carbon that can actually improve in terms of the adsorption and the removal of waste waters. So several optimization studies have been done. We did the contact time, pH, reusability as well. And we can see that the adsorbent can be reused as much as, like 5 times or 5 cycles. And for the adsorption isotherms studies also, we found that it's fitted best with Langmuir, with delta G values around -11. So mostly interaction is physical adsorption. And it actually fitted best with pseudo second order for the kinetic studies. So some mechanism that we have been proposed is that the electrostatic interaction could happen in the surface of the beads, interaction with the wastewater, which in this case we use paracetamol as the waste water from pharmaceutical industries. And the characterization of the beads after adsorption also shows the presence of paracetamol residues, which means that the waste actually been adsorbed on the surface of the beads. So as a conclusion, what I want to conclude in my sharing thoughts today is that we can see the application of oil palm biomass waste for many applications. What I have showed to you probably on corrosion inhibitors, adhesive, filler in coatings, and also adsorbent can also be used for other types, for drug delivery, for flame retardants, for composite and whatsoever. And the properties of the improved properties of the lignin, for example, is actually due to improved properties in terms of their aromaticity after modification. And for cellulose, after we do the acid hydrolysis and we obtain nano size of cellulose, this actually can provide a better surface area, which can give a better adsorption and other types of properties. So I would like to acknowledge, of course, my university, Universiti of Malaysia, for providing the research grant. And of course, to the collaborator from University de Lorraine, France. We actually have a very close research partnership with this university. I think I send my students every year to France for attachment, and I also visited the university like almost every year for doing research and for other activity. So Professor Nicola is actually my PhD advisor a long time ago, and we still collaborate with each other until now. So Isabel is the other researchers, Laurent and Francois is also the other researchers that actively involved in our collaboration. And finally, to my postgraduate students who have been working a lot on making this research a success. So to know more about the work that I have presented to you today, you can always check our publication, and you can actually come to us if you have anything in common which you can do in Malaysia as well. So with that, thank you very much. Terima kasih for your kind attention, and I'm happy if there's any question from the floor. Thank you.
Okay, thank you very much for Dr. Hazwan, and after that, it is very interesting presentations, Pak Hazwan. And after that, we are going to conduct discussion. Okay, don't hesitate to all to propose your question. Yeah, you are able to propose your question by chat or by raise hand, please. Okay, who? Yeah, we have just 10 minutes to discuss Pak Hazwan, and meanwhile we wait the questions from audience. I'm going to propose the questions regarding the instruments to measure corrosion protections, because actually in our labs just measure with the wheel test methods, loss weight, loss weight, and usually we have to send the sample to another university, especially ITB, because in Bandung just in ITB. And is that the completely instrument to measure like in the ITB, like photometric?
Yeah, basically, when we talk about corrosion measurement, we should have a potential stat. So the one that I presented earlier in the work that relates with the corrosion inhibitors, we actually undergo electrochemical impedance spectroscopy and also potential dynamic polarization testing. But we do also have another testing like electrochemical noise for localized corrosion and also cyclic polarization or cyclic voltammetry. Yep, I think in terms of the facility, in my lab alone, I have 3 potential stats. So yeah, I mean, like if there's any work that you want to do with regards to anti-corrosion property, you can always come to our lab. And I think, as I said, the potential stat is within our research lab, so it can be accessed at any time. And I think if I may share some experience. Before this, we used to have some attachment students from Indonesia, especially from Aceh, I think Universitas Syakola, and I think some other universities in Jakarta. I think recently we have a collaboration with UIN Jakarta as well, and they are also looking forward for the anti-corrosion studies as well. So that is why I mentioned that if, let's say, in your university you have some other researchers that would like to undergo probably like 1 week or 2 weeks of attachment to do all this testing, you are welcome to come, and we can use the facilities provided in the lab.
Okay, thank you very much, Pak Hazwan. Okay, is there the question? Okay. Okay. Meanwhile, the question from audience. Actually, Pak Hazwan, actually, especially me, we are going to research regarding the relates with your research, such as measure for wheel test method to measure inhibitor protections, research from the natural plants, yes, such as pacar Cina leaf, or kecombrang leaf, extract, and the extraction, the material that is such as lignin, and is the imaging Pak Hazwan already can applicate much applications such as except to corrosion protections and adhesive adsorbent, and especially for CNC nanocrystalline cellulose, because Actually, I'm hard to modify CNC because you have to applicate CNC because this is the limited scope. It is a hard scope of CNC is so the limited applications. Is this the opportunity for me to with the information with your publication regarding CNC applications.
Yeah, we can share the I think the publication, even the methods. The one that we are using to produce CNC is basically using acid hydrolysis. I mean, rather than other methods like mechanical, grinding or whatsoever. But I think the acid hydrolysis process is also kind of tricky because if we didn't actually adjust well in terms of the concentration of acid that we use, the temperature and also the time, it will actually burn the cellulose sample. So in the end, you will see that the cellulose is not white, but it become like brown color or whatsoever. So I think similar interest that we share with, I think now they call it as PRIN. Before this, it was called as LIPI. We have a very strong collaboration with BRIN Cibinong in Bogor. I think a few of their researchers that works on cellulose nano and I think lignin as well. Like we share the methods, and they also have came to USM to undergo several trainings, and I also visited Bogor before to see their facilities and give some training to them as well. So this is also other opportunity, which means that if you have a very specific, I think maybe experiment that you want to do, we can have like a joint training workshop, which I can share how the process can be done, or even if you want to have it like a hands-on training, you can come to USM and we can teach you how to do the acid hydrolysis, to do the pulping, and how to characterize the cellulose nano whatsoever. Yeah.
Okay, thank you. The last question, I think, actually, is there what kind of scholarship for to exam research assessment, to continue study, especially to master program, because we have the units, students achievement acceleration units, and accidentally we the hit, and we are going to encourage my students to propose to encourage to continue study to USM, especially for to school of chemical science. I think if much opportunity to get scholarship.
Yeah, I think probably some information that I can share as well is that for scholarship, there's opportunity. We have a so-called JRA assist. You can always check to our USM IPS website. And this call normally opens every semester. And it actually opens to a first-year student. It means that for students who wanted to pursue their master's or PhD, because they already obtained the offer letter from the university, they can actually apply. And this actually will support their tuition fees. I think they will give like for 1 year. But there's also another scheme, we call it as USM Fellowship, that can sponsor both, I mean the fees, and also it will give also the allowance to the student, be it from master's and also for PhD program. Other than that, I guess most of the time, if you want to register with, as a student with one supervisor, actually every researchers in USM, they should have at least one research grant, and this research grant are able to hire a so-called JRA. JRA stands for Graduate Research Assistant, and the amount allocated is actually throughout the projects. Let's say that the project is for 3 years, and for PhD, So the students can be benefit with the allowance, I guess, every month around 2,500 ringgit. I'm not sure in rupiah how much, but I guess it'll be several million rupiah around that. And this can be sponsored throughout the 3 years program. So I think probably if those who have any interest to further masters or PhD, you can always check to our IPS, Institute Postgraduate Studies website to look at their opening for scholarship. And this is actually applicable for international as well. For especially for research attachment, I guess this one it doesn't have any deadlines. So in case of if you are interested to probably do some attachment in my lab, for example, you can always email to me. I actually put my email address in the chat box. You can email your CV and probably give your proposal. So we can have something like an interview session, because I think the budget for attachment student is a bit limited, because we are going to sponsor the your accommodation, and probably some allowance will be provided as well. So there will be some selection, but normally we will take like around 3 to 4 students per intake, something like that.
Okay, thank you very much for Pak Hazwan. Because the limited time, I'm going to summarize this section, the primary section, regarding the opportunity to study in University Sains Malaysia. There are some opportunity like research attachment, and to continue study in USM. You are able to get via grant research, and for the research presentations, I conclude the modification via addition of organic scavenger for the smaller fragment lignin with high phenolic hydroxides content, and the second smaller lignin molecules with high phenolic hydroxides tends to give better antioxidant and reducing power. The higher mechanical strength of 50% OLVG adhesive was probably due to more cross-linking in the organosolved LPG resin structure, and the last improved characteristic of cellulose nanocrystal gave a better absorption and reinforcing properties. And that's all, audience, and thank you very much for Pak Hazwan, and hopefully we are able to collaborate again the next time, and excellent event. And Alhamdulillahirabbil alamin. Thank you very much for your attention, audience. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Back to Bu Risma.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much to the keynote speaker for the excellent lecture, and also I would like to thank you very much to Dr. Tety Sudiarti who has guided our main agenda. Para peserta yang berbahagia, link daftar hadir sudah dikirimkan melalui chat room. Mohon untuk diisi dengan benar karena sertifikat akan dikirimkan secara otomatis pada alamat email yang terisi pada form tersebut. Ladies and gentlemen, the last session of this event is the handing over the certificate to the speaker by the chairperson of this event, Dr. Tety Sudiarti. Please welcome.
Okay. For the first, thank you very much. Thank you so much. And I appreciate you deeply for Associate Professor Dr. Muhammad Hazwan Hussein from USM. And this moment I give certificate to appreciate you. Thank you very much. And we hope is this not the first time to collaboration, and then the next we are able to collaborations the next time, and hopefully we are able to meet you in person in Indonesia or Malaysia. Thank you very
Inshallah.
much. Inshallah, amin. Thank you very much. And back to Bu Risma.
Yeah, thank you very much. Well, ladies and gentlemen, the agendas we present you this morning have come to an end as we have finished our guest lecture. I am Rismawati Ramdhani and I'm signing off. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Pak Hazwan.
Ya, terima kasih Bu
Ya,
Tety.
big
Terima kasih
thanks.
semua.
Ya, terima kasih Pak.
Waalaikumsalam warahmatullahi wabarakatuh.
Jangan lupa diisi link presensinya ya, para peserta. Dan jangan salah menuliskan